Okay, before we go to the cost function, which is a little bit scary, let's examine some properties of these contingent input demand functions. Now, for example, you take the derivative of the demand function of k, which is a function of W, V, and Q0, right? With respect to its overall price, which is V. That would be like the derivative. So here everything multiplied. Now, so we could just write everything else constant and take care of this V only. So that will be, because the power of minus beta over alpha plus beta, so exponent go first, over alpha plus beta, times a to the power of minus 1 over alpha plus beta times q0 to the power of 1 over alpha plus beta, then times alpha beta over alpha plus beta, beta over minus beta over alpha plus beta, then times W, nothing changes, alpha plus beta, and times V, beta minus beta over alpha plus beta minus 1. That would be minus beta minus alpha minus beta over alpha plus beta, right? So that is minus 2 beta minus alpha over alpha plus beta. Or you can also simply write this. Good enough. Doesn't matter what the exponent is, you could see that A is larger than 0 by assumption, Q0 also larger than 0, alpha, beta, all larger than 0, and input prices. Yeah. And this one is smaller than 0, negative. So as a result, this is negative. That means when price of capital increases, the demand for capital will decrease. Quite straightforward. Yeah? Then what happened with the cross price effect? What happened to K start when the price of labor decreases? W equals, now let's go back here, labor is here, so exponent go first, beta, alpha plus beta, everything else the same, alpha plus beta, q0, 1 over alpha plus beta, alpha, beta over beta plus alpha. I messed it up, but still correct. Minus beta over alpha plus beta, W, beta over alpha plus beta minus 1. Now just leave it there, not important. So V minus beta over alpha plus beta could stay the same. Again, larger than 0, larger than 0, larger, positive, positive, positive. And this is also positive. So the whole thing is positive, larger than 0. Positive is a sensitive term during this special time. Okay? So, what does it say? It says that when the price of labor or other input increases, the use of capital will increases. So if labor gets too expensive, then they will substitute labor partly by more capital, which is actually what's happening here in Europe and developed countries, right? When the population getting old and also human resources getting scarce, it's more expensive with labor, then more capitals, more machines used, right? And the other way around for other developing or low-income countries with dense population, like for example my country in Vietnam, we have a huge amount of labor resources because population is growing and young people, so labor cost is relatively cheap compared to capital. So a lot of things like producing rice paddy, for example, in my hometown still involves a lot of labor work for that reason, because capital or machines much more expensive. Okay? And then the last thing, we could also check how the demand for input would change the capital when we wanted to change the production level. And here, where is it? Here. So that would be 1 over alpha plus beta times a to the power minus 1 over alpha plus beta times q0 to the power of 1 over alpha plus beta minus 1, and times everything behind it the same. And because all the terms are positive and 1 over alpha minus beta also larger than 0. I keep saying positive today, not good. That means the derivative of K, or input demand with respect to Q0 is larger than 0. So very intuitive, right? If you want to produce more, you need more input. Nothing else to say. Final thing, cost function will not be so simple, but don't let it scare you, okay? So cost function, what's written on your slide, is you plug I wanted to have like a space over there, okay? You plug the L star and K star to the definition of the cost, right? The total cost. So that is L star times W and plus K star times V, and because L and K star is function of input prices and quantity, so as cost. So that is W, V, and Q0. Alright, let's do it. So here we would have C equals W times this, right? So you only time W to the L start, so we will write everything L will remain the same because it's multiplication minus 1 over alpha plus beta times Q0, 1 over alpha plus beta times alpha to the power minus alpha over alpha plus beta times beta to the power of alpha over alpha plus beta, then times W. Take it slowly. So here we have W to the power to the power 1. And here you have to the power minus alpha over alpha plus beta. So that would be 1 minus alpha over alpha plus beta, which is, we have done that now, alpha plus beta minus alpha over alpha plus beta equals alpha is gone, beta over alpha plus beta, right? So W to the power of beta over alpha plus beta times V, the same, alpha over alpha plus beta, plus. Now it comes to the second things, the K star V. Now, so K star V, let's start from here. A to the power of 1 minus 1, over alpha plus beta times Q 0 to the power of 1 over alpha plus beta times alpha to the power of beta over alpha plus beta times beta over minus beta over alpha plus beta times W, let's see if I can make it, beta over alpha plus beta, and times V. Now minus beta over alpha plus beta right, and then times V, so plus 1, right? So that would be baby box minus B plus alpha plus beta, everything over alpha plus beta. The bracket should be here. So that means minus B and B gone, you have alpha left, right, over alpha plus beta. That's the cost function. A little bit messy, but don't worry, we make it. So let's say W, V, Q0 over here equals. Do it step by step. We have, let's see what is similar here. A to the power of minus 1 over alpha plus beta. The second thing is the Q0, also stay the same here, right? Sorry, okay, I cross it, I mess it up. Okay, so you could factor out these things already, nah? All right? And then that we have A to the power of minus 1 over alpha plus beta times Q0 to the power of 1 over alpha plus beta. What we still have in the bracket is alpha but now I will write it as fractions or quotients. So alpha over beta, but here's the same exponent. So we could actually write them as beta over alpha to the power of alpha over alpha plus beta, right? Because there's minus here, so it should stay in the denominator, right? Times W, watch out, here you have another similar thing again, right? The W to the power of beta over beta plus, and this V also has the same exponent now. But, okay, because I wrote that here already, we take care of it in a later part, okay? So, plus, right, because here's the plus. You have alpha over beta here to the power of beta over alpha plus beta, right? This is what we have in the bracket. And then rewrite again the thing with W and V that we just noticed. Beta over alpha plus beta times V to the power of alpha over alpha plus beta. Right? Okay, good. So now, if we put Q0 ahead, 1 over alpha plus beta, and you rearrange it in the way that you put A over here. Now let me rewrite it so that it's not confusing, okay? You see how hard it is to clean the board. It takes me quite some time when I have to clean it up and use it again for the next take. No. But that's fine. I enjoy it. I enjoy using the board, not cleaning it, by the way. Okay, so that is Q0 to the power of 1 over alpha plus beta plus. Okay. Then A to the power of minus 1 over alpha plus beta. Because I wanted to group this, everything in one constant B. So that it's not, doesn't look crazy all the time now. W to the power of beta over alpha plus beta times V to the power of alpha over alpha plus beta. This is the cost function of the Cobb-Douglas production function when it's minimized.